my name is Alex and welcome to my video series on learning electronics through experimentation. I recently just happened across a book that has a bunch of electronic projects inside of it with some brief descriptions on how they function. So I thought it would be a bit interesting to sort of go through the projects starting from the most basic ones through to the advanced ones and sort of just analyze what's actually happening inside of them. Maybe do a little bit of maths, maybe just sort of understand how components are generally connected and you might recognize some patterns. So maybe I'll eventually kind of figure out how oscillators are commonly configured and I'll kind of go from there. This is more so a project for myself if you want to follow along by all means, but I'm just doing this to sort of reinforce what I learn as I go through the book. In any case, I will see you down on the table, so let's take care. So I've taken the liberty of drawing up the schematic that was in the book, just so I can keep notes of it and do that as I progress through. I believe the main point of this experiment is just to demonstrate that a circuit cannot function if there is nowhere for the electrons to travel. So in this case, we know that electrons will flow from the negative of a battery terminal and return to the positive, but they can only do this if there is a complete path for them to travel. So in this case, when the switch is open, the light will not illuminate because there is nowhere for the electrons to travel. However, if you close the switch, in the sense of putting that to there, they will complete the path for the electrons and illuminate the light. There are components in this that will definitely need to be touched on in the future, such as the resistor and the LED. I am looking ahead of the book right now and I can see that they go into a bit more detail with the experiments for determining what they are and how they function. So yes, I will leave it at that. A switch is capable of opening a circuit and shorting one out, or in this case, just closing a circuit. I will bring that up on a diagram as well. I mean, a simulation, maybe, if I feel like it. But for the time being, I think that satisfies this one. I'll see you on the next one. So I've gone ahead and drawn up the circuit in a simulation program called FALSTAD. I might do that for some of the experiments if they're a bit complicated. I'm just doing it now for the proof of concept, and if it's not too difficult, I'll do it for a few more of them. But anyway, I'd rather use my actual equipment for a lot of the circuits instead of using a simulation. I've got an oscilloscope and a multimeter and all that stuff. In any case, we can see that there's no current flowing when the switch is closed. If you do close the switch, however, you can see current starts flowing from the negative terminal of the battery through the switch, the resistor, the LED, and illuminates it, indicated by the red circle appearing in the circuit, and then through to the positive. I don't actually like the idea of electrons flowing from the negative to the positive. That is actually what happens, but I am more familiar with conventional current, which indicates that electrons will flow. The current flows from the positive to the negative. So just for my series, I'm going to change that. I believe it lets me do that. 1 second. You know what? I'll do it for the next video. I won't waste anyone's time. That's that one. I'll see you in the next video, which looks like we'll be talking about resistors.